So how should we interpret this result? So Einstein says the way you interpret it is, it was like this the whole time, nothing surprising. But then we try to do experiments to see if that's the case, and what happens. So there's a famous person that comes into the story, who John Bell. And so what does Bell do for us?
I mean, basically, to put it simply, he finds that any kind of simplistic Einstein-like description where the thing had the definite configuration before we did that measurement, it can't explain the results. So you just
so when you say the results, you're talking about observational results.
That's right.
So he writes this famous paper. What year? Is this 1964? I think this.
Something like that, yeah.
I think it's like 1964. He writes this famous paper where he surprisingly is able to get at an experimental consequence of an Einsteinian view, that things are definitely up or down before you look. It's just the mathematics that's giving this weird superposition quality. And then people go out and ultimately, starting, say, with John Clauser in this must be the 70s, and into 80s with Alain Aspect, they carry out the measurement, and they find, as Mark was saying, that the Einsteinian picture doesn't describe the actual data. So if Einstein were here, I think you'd have to conclude not necessarily that quantum mechanics is complete, but the chink in the armor that he thought he found isn't actually correct.